it's been amazing so far, and I met amazing people. So I'm very glad about that. And I'm also very thankful to Seven Principles for the invitation for this. So yeah, this one that has just been publicly released with iOS 12. And we're going to talk about a lot of things with it, but I want to make sure, I want to know one thing first, is that who already use ARKit here, please raise your hand. So an idea of how technical, what should I say? Okay, so there's not that many people saying. So yeah, here it is. First, very quickly, my name is Falmer. Is it working? Is it working? I've made which I released in as the first Twitter AR client, entirely made with ARKit and SceneKit. Steps that I will show you later. An AR business is waiting for, and an AR restaurant very active about AR. If you here's my Twitter, and I also have a newsletter that I created 2 months ago called What's Up ARKit that you can come, and also available on Medium if you want to read about it and see every week the cool stuff like Manu's work. And yeah. So the different parts we're going to see. The new features. So I just added the steps of creation of an AR app. That's going to explain to you a little bit how I've made them, and I'm going to show you a little bit of my drawings as well. And then we're going to get into, I think, 2 of the most important features of ARKit 2.0, which are the image live tracking and the persistent experiences. So first of all, I would like to show the eyes tracking feature. So because we used to be able to have a lot of tracking on the face, but now we can actually see exactly where the person is looking. So, and I didn't tell Brad Dwewer that I was going to put his face here, so I think he's going to be pretty happy about it. And this is an example, a use case, where someone is actually using it for an accessibility feature. So he's controlling it and actually can click on the button with it. So that seemed like a funny thing, but that actually has some proper use case with it, even though it's still very new. There's also the environment texturing. So you can see now that you have mirroring possibility on like metallic or mirror textures, which is very new. So you can see really the mirroring aspect. So that's pretty nice to make really realistic objects that you put in the real world, and sometimes it's even harder to tell if it's a real object or like a virtual one. There's also the AR Quick Look. So this is using the new file format that they unveiled called USDZ. And Shopify already integrated it. So you can see it on this website, Magnolia, which is Shopify. And you can see you can directly put the object in the real world, in the real size. A little bit like the IKEA app, but like really easily, and for like you can have it on any website. And Apple also really recently added on their website documentation to add it in news articles. So after when you read an article, for example, also in the Apple News app, you can actually have these features. There's also the 3D object detection feature. That is very interesting. So you actually are able to scan a 3D object, and or I should just say an object, because I guess objects are 3D, and actually after like be able to recognize it and show some content. There's also the persistence that I'm going to explain later, and the share, and you can also share. So this is also from Brad Dwyer. It showed a small example, so you can actually see in a kind of a little game, a little FPS, how that could work out. So you can actually see the two people interact with each other, and this is when they play together. You see, so with a. So you see, so that's a there are a lot of possibilities, and you can actually, aside from the game, there's also tons of possibilities. And now, we're gonna get into the image live tracking. Image live tracking is really, I think, the feature that's been used the most since the release of the beta. Everybody found a lot of different ways to use it. So I'm gonna show some of the best work that I've seen, and also my work as well. So here is a catalog of watches, and you're actually able to recognize it with image live tracking and then see it on your wrist. So the video is actually pretty long. It tries tons of watches, but I make it simple. But it actually worked very well. And for the fun fact, he actually told me this is a 2D images, but it actually looked very real, but it's actually just a 2D image of the watch. This is an example, so this was from Jacobo, this is from Nathan. Nathan has been very active. He showed an example in the museums, how you could actually recognize the different characters of a painting and then get a very custom description. And you see, if you just are in front of a painting, you were wondering, oh, what's this guy is doing there? You can actually know. And this was another example from Nathan, which is a way to add content to the Apple Watch. So you can actually see your pictures. You can read your emails, messages. You can see the weather. And this is really the interesting part about AR, I think, at the beginning of AR, is that we're actually going to see a lot of content added to things we're used to use, but in a very smooth way and very user-friendly experience. So this is very user-friendly. This is one of my work. This is an AR restaurant menu. So basically, I designed this menu. This has no link with the place I'm at. I just chose this place because it was a spritz and it looks nice for the video. And you're going to see how it looks like. So I designed it so it's pretty convenient. You can see 3D models of food going around. You can actually have the reviews about it, and then actually see more details. If you click on it, you can actually see more about it and actually be able to choose what you want to eat. And next, this is the AR business card that I've done. So it recognizes a card, and then it shows what I've done before. So Twitch Reality, which I will show you later. And this is a real web view, by the way, on the right. So that's pretty nice. I'm actually going to show you this in real life right now, so you can see how don't steal it from me, please. So you can see how well made this is. It's very smooth. Yeah. Okay. Okay. Up. Yeah. So here it is. Can I do that? Cool. Okay. So you're gonna. So what should I do? Yeah, maybe I'm gonna go on you. Sorry, but you're gonna see yourself. So look, it just recognize. Oh, it does a no. Okay, it recognizes, and then you see in a very smooth ways. You see, it's really smooth. So that's the good part about it. That it's really realistic. You see. And I can even put it on the table, even though this is my computer, it doesn't really make sense. But you see, it works. So yeah. So now we're going to get into the steps of creation of an AR app. So as a lot of people never did yet an AR app, I want to show you about a little bit the thinking behind and how to create a good experience and something that really catch the attention. not just like maybe a vase, like something a little bit maybe in the future of what's going to happen. So let's see. So yeah, first of all, I want to show Twitch Reality. So that I spent a really long time working on the end of last year with ARKit 2.0 because I thought it was really inspiring, and I was thinking, you know, what can we do with this? What are we going to see in the future? Why Apple is doing this? So I tried to make something that actually represent what we could experience through AR glasses in a long-term way. So this is actually through the iPhone screen device. It's not any Adobe After Effects or anything. So this is what it looks like. So you have all the tweets that you used to read in a sphere, and you can actually interact through the screen with the different elements. So I try to recreate kind of the feature we used to with Twitter. So like being able also to scroll like you see with comments, and also if it's a reply, what's up. And also you can have on the side all the features you're expecting. So notifications, you can write a tweet with the arrows, you can actually scroll below, kind of. So that was a big part of my work. And yeah, so that's a bit the figure. So it kind of a little bit lost out of my control. That was pretty crazy. And that's also why I'm here today, because of this. So I'm very happy about it. And I want to share with you what are the different steps for creating an AR apps. In this part. So first of all, the ID, then the research about the user experience, and then we're going to get into the craft of it. And then I will get very technical. Don't worry, I will show you a lot of codes. I will show you how we code this and everything. So yeah, first of all, the ID. What I had in mind, and I think a lot of the things we've seen in movies are holographic displays like this. So that's where I got the ID, by the way. And but in reality, when you actually draw your ID, it looks like this. This is the original drawing of Twitch Reality. So it's much less impressive, but you got to start from somewhere. So the question to ask when you're crafting this is, what will the future look like? So is it to the iPhone X, like this beautiful screen and everything? I'm not so sure. I think for me the future could look more like this, which is a little sci-fi short film. You can actually see how the content is implemented in every single corner of your room, of your environment, in a very smooth way. It's not aggressive at all. That's pretty nice. About the UX, we have a lot in mind. I think one of the first thing was a Pokemon that was on an iPhone, because it blew up and everybody loved it, even though it was a very, very beginning of AR. And yeah, and so no, I forgot what I wanted to say. So yeah, so this is what this is one of the first thing. But I think in fact to create the UX, you have to really think about how the users gonna interact with the content. So I've actually never shown this before, but this is where the first drawings were thinking if it could be, for example, in a cylinder. But I realized that a cylinder would be really not nice, because you would have to like go up and down. And you want people to not be tired. You don't want them to go up, down, go on the side, having to move around too much. So that's why I ended up with this sphere, and yeah, different ways of interacting with the content, and yeah, just some little bit of math. There's also big, very important, the animations and tutorials when you're building the AR app, because I think one of the biggest mistakes that have been done by iOS developers or developers in general doing AR is that they kind of forget that at the beginning it's really hard for a user to handle AR, because it's a very new thing. People are not used to it. So it's very important, like the IKEA app, they did a great job, and they worked together with Apple because they presented it very early. So that's a pretty good example. And that's actually how I did it, and that's actually one of the reasons why it worked so well, because as you're going to see the full process before you actually see the sphere, I tried to make it as smooth and as quick as possible. You're going to see. So it looks like this. You have this very small, this is the only 2D view you have, and then up. That's it. It's going to, you have to just to scan the floor. I hope I'm going to do it. Yeah. And and yeah, you look up. You see, it's here, and then there's an animation. So I did all of this in the way of thinking how the user would actually appreciate how smooth it is. And by the way, the scanning process is also the part for me to actually prepare the content, and I'm actually loading tons of stuff, so that makes me win a lot of time that the user doesn't even know about. And then we're going to get now into more of the technical aspect, and we're going to get into the image live tracking. So we're going to see how it works, the feature and the limits of it, and the code example. So I'm going to show you the code. So first of all, we get the image on Xcode. This is the original image. Then they're going to make a grayscale version of it. And then they're going to find image encores. So basically, they're going to find like spots that are very contrasted, where you can actually very easily understand, easily recognize the image. That's why so it looks like this. And that's why there's a best practice things I wanted to tell you, that it's really important to have distinct features, well-textured, good contrast, no repetitive structures. For example, if you had a full, a page, and you had a logo, you're not going to recognize the page. You should recognize the logo, because the logo is unique and is very easy to recognize, and then maybe make the content appear around the logo. So it's very important to choose exactly what's going to be recognized. So there's also, at the moment, according to Apple, there's a little bit more than 25 images that you can recognize at the same time. This goes, I've heard that some people succeeded to make it work up to 40, 50 images. You tried, Manu?
It depends on the device. On
Yeah?
you're done with 10.
Yeah, okay, so it's a bit the limit right now, because it looks really amazing, but this is using a lot of processing power. You can use different sets of images, thankfully, so you can have different sets of 20 images. So let's say you're in a museum, like we saw earlier, you could actually go in a room, have like 20, 30 paintings that you can recognize, and then when you switch off room, you can actually switch off sets of images to track. The good thing is also that you can load image to be tracked on the go. So that means that you can actually have images on a server that you load right now, and then that the user is going to be able to recognize. The only thing that you don't have, that's why I said without Xcode analysis, is that on Xcode is going to tell you, after studying the image, if it's a good image, if it's well textured, if the quality of the image is good enough, and if it sucks, it's going to tell you. So you could be able to change it. And in my case, what you saw with the ARCore is that I try to make a normal thing with a virtual content under it that appear on the side, goes up in a very natural way. So I just wanted to make this little explanation, because it looks smooth, but that's what happens. So that's what I'm doing. You're going to see later, I change the opacity, I move on the side, move up, and then at the end, it looks like a normal thing. And this is using the occlusion. So I was going to say it, and I don't know if everyone knows about occlusion. So occlusion means hiding virtual objects behind real things. So for example, when I was using the card, actually, this is what I'm going to show you later. There's a plane that hides the content behind the virtual content. That's why you couldn't see any content behind the card, because I put a transparent card that hides basically any virtual content behind. So we're going to see about this later. About this, that is very important. When you create, so on SceneKit at least, when you create a SCN plane to do this, you're actually going to do an alpha mask to make it able to do this effect, so to make that everything disappear kind of behind this, everything that is virtual disappear behind this plane. And also, it's very important to put the rendering order to -1 to make sure this is rendered first, because otherwise you're going to still see the content, the virtual content, behind the card. Yeah, so let's get into the demo. Yeah, so that's it. So I'm going to show you a little bit the different steps, and you're going to see that it's overall pretty easy. First of all, you set up just the AR configuration. There's two main AR configuration, which are AR world tracking configuration and AR image tracking configuration, which is specifically made for this. So you initialize kind of the resources, the images that you're going to track here. Then you get to set up the overall configuration is the AR image tracking configuration. You then choose the images that you want to track, the maximum number of tracked images at the same time, because you can actually, I didn't show this example, but you can actually have different image tracking at the same time. Oh, too small? Okay. Sorry. Hop, la, la, la. Voila. So that's it. And next, so that's when you actually detect the image. So it's going to get what is the current reference image. So that gets that the card is here. Then I create the occlusion plane I was talking to you about, which actually going to hide the virtual cards that are appear from behind. So you see actually what I did. The alpha, the rendering order -1. The opacity is 1, so it's fully invisible as well. Then we'll see, to make it pre-user friendly, I did a shining animation that you will see again. I saw earlier. So it's pretty simple. It's actually from the Apple example of image tracking, and I thought it looked pretty cool. So here it is. It just, again, I'm sending the height of the width of the real card, and then it's gonna create a white plane that's gonna shine. So that's the animation under it, the Apple animation. And then we get the plane from behind. So this time, in this very simple example, I actually gonna do a copy of my own card, which I'm gonna show you. And this is it. So yeah, this is you see it creates with the same plane with the same width, same height. I choose the image. I put the position. You see z minus 0.005, so it's just under it, and then just a simple animation to show it around. And one thing I forgot is here. Yeah. So here it's too small. I don't know how to. Basically, the card is here, and here it's written the real size of it, so you can see in centimeters. I actually it's a specific thing. So you put your image, and then if the image sucks, basically they're gonna put a little warning message, and they're gonna tell you why you should change your image. And then here you're gonna be able to choose. And this works as well for small cards, but as well for billboard size. Someone actually did a real-life ad blocker where like all the billboards are switched to whatever you want. So that's actually possible. And yeah, I'm gonna do a demo of what we just coded. Let's see that. Does it good? Yeah. Okay. So you're gonna see it's exactly what so here it's gonna detect it. It does a shining animation, and then you see under it there is the copy of the card. I wish there was the same lighting to look like it's almost a real thing, but the lighting is blue, unfortunately. So yeah, so that's it. Pretty easy, as you see. I think the total of lines was very little. Let me see. Yeah, it's 110 lines, and I even jumped some lines. So it's actually pretty easy to do. It's just a question, your imagination. So they make it pretty, very user-friendly for developers. That was it. And, sorry. Now we're going to get into the persistent experiences. So originally I wrote, I don't know if you read the description of my talk, I wrote that I was going to do the 3D object detection. I was going to talk about this. The reason why I changed is that basically there's a very few people that actually did with things with 3D object detection, because it's currently very limited, as you can only have an object of a furniture size on a table. So you cannot have a statue, you cannot have you need to have pretty small things, and you need also things that have no reflection, you know. So a lot of things have actually a lot of reflection. So that's why I prefer to talk about persistent experiences, which actually you can very easily move from this to actually a shared experiences, like a multiplayer experiences, like we saw earlier. So yeah, at first I want to tell you a little bit the differences right now for persistent experiences, because it's still all new, and yeah, so the good things to know is that ARKit is basically based on a class, so which make an object AR world map, which this object is totally offline, so you can actually take this object and put it on a server. There's no time limit, and it's only compatible with ARKit, whereas ARCore is compatible. What they did is compatible with ARKit and ARCore for like the mapping of your surrounding. But the thing is that all of these anchors are online, and they are only available for 24 hours. And it didn't change. I checked yesterday. It's still 24 hours. So this is actually very limited, because if you were, for example, making in your own apartment, someone can create some kind of their own AR environment or AR stuff. With ARKit, at any time you can actually put it back again at the same place, whereas with ARCore, it's not really currently possible. This is quickly the different components of AR world map. So they are the anchors, which can be also the object that you're going to make appear, the center, the size of the world map, and the raw feature points, which I think, which are AR point cloud thing. So one picture for menu, and here we are. With AR World Map, the best practice is to actually take different point of views. So a little bit to move around. So it's going to be able to scan really the surroundings in a static and well-textured environment. I saw you. In a static in a static and well-textured environment. So that means you cannot scan humans because they're going to move all the time. So you have to make sure when you're doing a scanning that things don't change all the time. And also, you have to make sure that you have enough feature points, so that you scan enough and that there's enough points for it to remember it. So that's why they also did this instance property called world mapping status that lets you know if it's the quality of the scan is good. So it's pretty nice. It's gonna do this. It's gonna be first not available, then it's gonna be limited, and then extending and mapped, and it's go back to limited when it discovers a new surrounding that is never seen. So that's how it works. It's pretty easy, like everything with ARKit. It's pretty easy. Is that you have the AR world map object, you archive it in a data object, and then you save it in the device's local directory, and you can get it back then in the other way. So that's pretty smooth. I'm going to show about it right now. Let me see. Yep. Even bigger? No? Okay, it's good. So first of all, what the app is doing is basically I'm adding a text on the floor. So first of all, I had to recognize the tap gesture. So it's not very interesting, so I skip it a little bit. But that's when you get where the user is tapping. Then you're like getting exactly where in the world it is, and you're going to actually place your object on it. And then that's a part I want to show you about the persistence. I think no, okay. It's the saving part. So basically, what you're doing, please remove, what you're doing is that you get the current world map, and then, why did it fail? Oh, something after. So you get the current world map, then you check that you have it, and then you're going to archive it with, here it's the device URL, where it's gonna where it's gonna be saved in the device, and then you're gonna archive it just here. So it's pretty easy, pretty smooth, and then you can even switch off app and get it back from another app. So that's really well made. And then you're gonna have you're gonna be able to load it. So I think it should stop all the errors around because you're gonna see in the demo. You have actually a button, so it's gonna retrieve it, then it gets it, it checks if it's there, then it's gonna unarchive it, and then you're gonna get it back. So that's pretty simple as well. You see there's 140 lines. Then after I just added a few things, which are you see it's an AR world tracking configuration because earlier it was an AR image tracking configuration. And there's, as you can see, plane detection is only horizontal because it could be as well vertical. And it shows feature points, so you're going to actually be able, because we were saying it's very important to have a lot of feature points that are very dense, so we're actually going to be able to see them. So let me show you. Let me show you up. Okay, so as you can see, it's going to, you see all the feature points, they are here, and the mapping quality is improving, and then if I go up, you see extending. And then it has to map it again. So it's pretty simple example. And then I'm going to add, you see, SwiftConf 2018. SwiftConf 18. So I just put it out there. Pretty simple. Then I save it. world map is saved. So now I quit the app. I force it quit, you see. So I'm done with it. I get it back. I redo the scanning. I'm going to scan a lot because otherwise it's not going to recognize. Okay, and then if I do loading, okay, it should take a few seconds. Yeah, here it is. You see? So that's very smooth, and that actually lets your user be able to create an experience and then get it back later. So yeah, then now we're going to get to the conclusion. We saw about image tracking. So to sum up, image tracking is very powerful, works great. Only limitation, 20, 30, a little bit more maybe, images right now with different sets. So you can actually change the set as much as you want. It's also possible with any different kind of size. So you can have very huge billboard as a small card. And the persistence can be easily switched to the sharing experience is very powerful as well. And that's why I want to show two last examples of something that is getting bigger and bigger right now, and more startups are getting into it. It's kind of hard to follow. It's all the indoor AR location. So this is a really recent example that I've been sent, where it's in offices and they actually mapped it. So you can actually choose where you're going, and it's going to go all around. And you have a persistent experience that could have been saved before, and you can actually find the way. So you see, it's very smooth. And this is all the indoor location work. It was telling me, so it works for EatPocket, that they were working on this for a client. And yeah, so there's a lot of different possibilities. And maybe something you have seen from Andrew with his startup, Dent Reality, that is done a really amazing job with an AR shopping experience. So it recognizes it, then you can directly see about it, and then go to your other product and find the way in the supermarket. He personally told me, I met him recently, and he personally told me that when he was doing this, the security guard almost threw him out of the shop because he was scanning all the time, all the shop. So they were like, what is this guy doing here? So yeah. So you see, pretty smooth. Thank you.
I have to turn it on. All right, do we have question? I mean, I hope this last example you showed also works with vegetables.
It works for vegetables.
Okay, because I was not so crazy about augmenting my reality.
Maybe you can use machine learning for the vegetables as well.
Yeah.
With CoreML.
Yeah, I wasn't so crazy about augmenting my reality with dead animals. Anyway, I like the concept of diminished reality, by the way. The thing you said about blocking ads, because that seemed like something I never thought about this, but there are so many stuff out there which are just something you would like to remove instead of edit. Questions, anyone? Otherwise, I actually have one which is not from me, which is from the chat room. I think I know the answer myself, but I want you to answer to the person who asked on the chat, which was wondering what's the difference between ARKit and ARCore. I think ARCore is the technology for Android, right?
Exactly.
Okay.
And
maybe you can go back very quickly on this slide. Did you try it? Did you give it a try on Android or not? Or did you just get those information from somebody?
This is actually because I had an idea, and I didn't want to build something big that I couldn't scale to Android. That would have been super frustrating. So is it working or not? Yeah.
It's working.
So that's why I checked all of this. But otherwise, ARCore is also very powerful as well. The only thing is that as they made it very user-friendly and very for developers as well on ARKit, most of the cool stuff is made on ARKit. So I'm working on it, but I don't say anything bad about ARCore. As you can see, they also have a compatibility with ARKit at some point for the AR Cloud anchors. So that can be interesting too.
But the killer is online, right? You have
No,
to be
the thing I was meaning by online is that the cloud anchors are saved online, so which means for 24 hours does
Okay.
it work? So, so the thing is that after 24 hours you can't have the feature points I was showing you.
okay.
Whereas with ARKit, the good thing is that you actually have kind of power on it, and you can actually save it on your database or on the device.
Any other question? Yep.
Awesome lecture. Really enjoyed it. I want to ask, first of all, that example you showed in the supermarket with the traveling, how does that work? What is it tracked to? Because it is beyond the visible spectrum, right? You see the directions and then they continue beyond what you see on screen. So what is that attached to?
I think so. What the thing is that to create like a cool experience like this, he uses occlusion on the wall. So it means that on every wall, there's basically, like I was showing you, like a transparent, I don't know how to say that, plane. So basically the road is not going to be like on the first example where it was showing you could see it in the middle of the walls, which doesn't make sense. So first of all, to make a very smooth experience, you make the occlusion everywhere you can. And that's why it's better to scan it before. And then after, there are different ways to actually save it. I don't know. He told me a little bit, but I can't tell because it's his work. But there are different ways to actually make it precise. I think one of the current challenge is to have a very precise degree of where you are, because it's not super precise. So I know he told me he found some secret ways to do it and to make it super smooth. That's why I say I can't say anything. But there are different ways, and people, like I was telling you, everybody's looking at it. It's all very new, and I think it works. I'm confused.
It works.
And
It works.
the interesting thing, I'm sure it works. Allô? J'ai coupé mon.
Try with the other one.
Hello?
1, 2,
Okay.
1,
So the
2.
interesting thing I wanted to say also is that that's also why the reason why ARKit is really the thing to get into right now, because a lot of people yesterday and today ask me, oh, but like, is it really useful right now? Like, there's no killer app right now at the moment that we're actually using. The thing is that it's more a middle to long-term game. As it's gonna get bigger and bigger, people are more and more into it. And the thing is that if you're building something now, you're actually gonna stand out, and people are actually gonna notice it because there's not much that has been done. So if you have a pretty cool idea, there's a lot of chance that it's a really brand new idea. And so that's why, even though I know for you guys that are working in big companies, it's not a first goal to go into ARKit, but the cool thing you can do with it is actually implement a side feature of it, and a fun thing that's going to be like more like a wow feature, like a wow effect. I think for now it's usually more like this. Aside from the indoor locations AR experiences, which are also really possible right now, as it's pretty convenient to walk around and actually see this kind of stuff. And I think we're going to see more and more in the upcoming months as iOS 12 just been released.
Yeah, just a question, and just before you, I saw when you ask who has worked with ARKit, I saw a few people from 7P showing their hand. Is it something you guys do at 7P, or it's just their pet project? You are doing something? Can you speak about it or not? Okay, product placement. Okay, because this is important to have actual implementation of this stuff in real world things outside. Go ahead.
The indoor location, is it done with beacons or something? Are there any connections with the beacons Apple introduced some years ago? With
I guess you could link it with it.
Okay.
Didn't, but,
you can use it to retrieve entry points and things like that.
I'm sure you can link it. I'm sure.
was-
I don't see any problem with it. I don't think anyone did it yet, but it's doable.
Okay.
All right, so this is the moment where we give Oscar a round of applause.